Okay, welcome to Add, Subtract, Like Fractions, page 284. Okay, my name is Mr. McCullum, and take out your notebook. Take out a notebook. Okay, take out something to write with. Pen, pencil. I got my trusty digital pen here. And maybe different colors, markers, highlighters, anything that's going to help you with your notes. Okay, so what we're going to do here is we are going to go through every part of the notes for add, subtract, like fractions. Okay, so follow along in your books. Yes, you need your book out. Yes, you need to take notes in the notebook. These are all questions that come up in the chat quite often. Okay, so go ahead and let's take a look at this. Page 284. Now, essential question. Yes, you got to get this down. What happens when you add, subtract, multiply, and divide fractions? Well, today we are going to take care of the add portion of this and the subtract. Not all of the add and the subtract, but some of it. And of course, we're taking care of fractions. So we're going to help you to understand what happens when you actually do the adding and the subtracting. The only difference that today's lesson, we're going to have another lesson in the future, but what's going to happen is this is of like fractions. So we're going to talk about that, and that is one of our vocabulary words. What does it mean to have a like fraction? Okay. So let's take a look at this. We get our first one. Remember, I put a bunch of stuff over here on the right. This is all the stuff in the book. So if you can't see it, look at your book and look at it. Basically, it's telling you how to do the problem. However, I'm going to do the problem with you. It might change a little bit the way they do it, but that doesn't mean that they're doing it wrong. It just means they might be doing it a different way than the way I'm doing it. Therefore, you might have one or two or maybe even three different ways on how to do the same problem. Your choice is to choose the best way you feel works for you. Okay, most of the time it's the same. Most of the time. But there are a few times where there's multiple ways to do the same problem and we still get the same answer. That doesn't mean that those multiple ways are wrong. It's just one way fits for one person versus another way for somebody else. Other things that we add in here, it's help us to think. Okay, like this little graph here is going to help us to think what's happening. This is more of what's happening in our head or explaining out. Anytime we draw something out is more of what we're trying to think about what's happening with the problem. And I want you to try to do that every time we do a problem. Okay, so let's take a look at number one. This is our first example. We have 5/9 plus 2/9. This goes all the way back to when you first learned how to do fractions. And like fractions means they have the same denominator. That's a big thing in fractions. Now, all of these are going to have like fractions. So all of our fractions today are going to have the same denominator. Very, very nice. Makes things very, very, very easy. It's just that we're going to add in some integers to complicate things. Okay, but when we have like denominators, what we're going to do is we're going to say, okay, well, this has the same denominator. So what I'm going to do is I'm going to draw my fraction bar, and I'm going to put my denominator here. Because it's the same, I only need to write it one time. And then in my numerator, I'm going to write the operation. Okay, so I'm going to use my highlighter, and I'm going to go ahead and change the color. Let's use, and I'm going to use this right here. This part right here. Okay, I'm going to use 5 plus 2. So what I've done is I've converted this out, found the like denominator, I converted it up, and I put in my numerator 5 plus 2. Now you just have to simplify. That's just basically what you're doing now. You're simplifying 5 plus 2. If you said, oh yeah, 5 plus 2 is 7, you would be correct. And we're going to keep our denominator the same. Now, if you have to reduce here, you can go ahead and reduce, but for right now, we don't have to. 7/9 is in simplest form. So our answer here is going to be 7/9. Let's take a look at number 2. Number 2, I see we have negatives, but notice the most important thing is my denominators are the same. Now I said that at the beginning that all of our denominators are going to be the same when we're doing this lesson, but in the future you're going to get different denominators. You might have them to be the same, and sometimes they might not be the same, so you always have to check first. So yes, we have like denominators. Because if you don't have like denominators, I don't know if you know this or not, you're going to have to change them so that they are like denominators so that we can add and subtract them. So here we go. I'm going to rewrite this problem now. And my denominator is 5, so I'm just going to write 5. But in my numerator, let me grab my highlighter. I'm going to highlight everything that I'm going to put in there. I'm going to put in a -3 plus a -1. Do you see all that stuff that we got to put there? Because we had a -3/5 plus a -1/5. So really what it is everything's over 5, so it's a -3 plus a -1. And you're probably going to want to put some parentheses in there so you don't get the plus minus in there. Okay, so now you do the same thing that you would do in adding integers. You would have 3 negatives, 1, 2, 3. You'd have one more negative, 4, which would give you a numerator of 4 negatives over 5. Now you can put the negative here. You could put the negative on the outside. Okay, there's 2 ways you can write that. You can write it this way. Actually, there's 3 ways. Or you could actually, and this is very rare, but one of these is negative. Now, if both of these are negative, then it becomes more of a division. And negative divided by negative becomes a positive, so you don't want to do that. You want to keep these, one of them being negative. This is the way I usually prefer, putting the negative in the numerator. That's my preference, but that's just me. I've seen it plenty of times like this. In fact, you can see it like this right there. But look at either or. Rarely like this. Rarely. Okay, but I have seen it. It's kind of frowned upon, but I have seen it. Okay, it's your turn. I want you to try to do these too. Do these right in your notes. Good luck. Okay, welcome back. Hopefully you got those right. If you didn't get those right, it's okay. You can replay the video. You can pause the video at any time. You can take the notes down better. You can rewatch the video if you didn't understand it. On the left side over here, of course you can't copy my screen, but what you can do over here is write questions. So if you go through here and you're like, I just don't get that, Mr. McCollum, write out what you don't understand, and then when we see each other or we're in our meeting, you can put that in the chat. You can raise your hand, ask the question, and get that answered so that you can be that better of a student. Because remember, students have questions, and the more questions they could get answered, the more they learn. And the more they learn, the better they do on quizzes and tests, and they're happy because they have good grades. It all goes together. Okay, so number 3, example 3, basically now is our word problem. Sophia ate 3/5 of a cheese pizza. Jack ate 1/5 of a cheese pizza and 2/5 of a pepperoni pizza. How much did Sophia and Jack eat all together? Okay, so take out my highlighter here, and green is going to be, okay, we'll do pink for Sophia. Pink. Sophia ate 3/5 of a cheese pizza. You don't even need to mark cheese pizza if you don't want to. Change it to green for Jack. Jack ate 1/5 of cheese pizza, but he also ate 2/5 of a pepperoni pizza. Okay, so Sophia's, you have 3/5, and they want to know eat all together. All together means to add, if you didn't know that. 3/5 for Sophia, and then you're going to have the 1/5 for Jack. And then you're going to have the 2/5 also for Jack. And they want it all together. So we can do the same thing here. We're just going to have one big line. My numerator, okay, the pizza place must have cut all the pizzas, the cheese pizza and the pepperoni pizza, into 5 equal slices. Of course, this has to be equal. How do I know they're equal slices? Because it told me 5 is the denominator. Must have been the same guy cutting the pizza at the pizza place. Probably makes sense. Who knows? Maybe they have a robot that cut pizza now. It just comes out cut. I wouldn't be shocked. Just makes time faster. Okay, so 5, that goes here. Same denominator, same thing, like fractions. Okay, that's what makes it like. Then up top, you're just going to take your 3 plus your 1 plus your 2. 3 plus 1 plus 2. Let's think about that. You got your 4 plus your 5 plus your 6. Okay, so you're going to end up getting 6/5. Well, you can't leave it as 6/5. Now I'm going to have to show you how to take an improper fraction and make it into a mixed number. So how do I do that? You're going to take and you're going to go through. It's almost the same as dividing to get a decimal, but you're not going to get a decimal. You're going to end up with a mixed number. So let's see how you do that. You take your 6 and you divide it by 5. Hey, because that's what we do. It goes in 1 time. 1 times 5 is 5. We subtract, we get 1. Now I'm going to show you some things. Okay, the 5 is still the denominator. Okay, so let's highlight this stuff out. 5 is still our denominator. It's always been our denominator. Nothing has changed. So don't change it now. Okay, my 1. Okay, well, how many times? What was my remainder? It was 1. So let's take out my highlighter. Let's change the color. That's why the 1 goes there. How many times did it go into 6? It went in a total of 1 time. So it's 1 1/5. Get my highlighter out. Again, change it to orange. There you go. 1 1/5. I have a whole number. I have a fraction. And together we call that a mixed number. Little review for you there. Okay, let's continue. Your turn. Remember, you can pause this at any time you want. Go back. Good luck. Okay, example 4 and example 5. Now we get into subtracting. So we've done our adding. Now we're going to do our subtracting, but it's okay. You got a -5/8 minus 3/8. We're lucky because our denominators are the same. So I'm going to draw a line. I'm going to put my 8 in there because it's the same. And I'm going to put out all the stuff that's in the numerator. So let's do a little highlighting again. Let's take a look at that. Everything that's in the numerator is going to be -5 minus 3. All that stuff is going to go in there. So let's find out. What is that going to look like? -5 minus 3. First thing I think of, and let's see if you guys can think of it. I don't know, maybe write it out. Add the opposite. That's right, we're doing integers. Add the opposite. I'm going to rewrite this. -5 plus a negative 3 over 8. Now, what do we got here? We have 5 negatives. We have 3 negatives, which is a total of 8 negatives. You get a negative 8 over 8. That's division. 8 goes into 8 one time. It equals a negative 1 because it's negative. So that's reducing. Okay, if you do this in ALEKS and you put negative 8 over 8, it's going to tell you, please simplify your answer. What does that mean? Do a little bit of division. Think of it as a problem where you have to divide. 8 divided by 8, don't forget it's negative, and go through it. Same thing for number 5. Don't leave any subtraction up to chance. We're going to draw our line. This is 5/8 minus 7/8. 8 and 8. I'm going to take my highlighter out again. Highlight the 8s because they are the same. They are still like fractions. Put my 8 here. What is going to go in my numerator? Well, it's going to be 5 minus 7. You should be getting good at it now. 5 minus 7. Now some of you are thinking, wait a minute, I can't do that. Well, think of add the opposite. Okay, add the opposite. Let's rewrite this. Let's go 5 plus a negative 7 over 8. 1, 2, 3, 4, 5 positives. 1, 2, 3, 4, 5, 6, 7 negatives. Okay, these all become zeros. I get a negative 2. My answer? Negative 2 over 8. If I put that in there into ALEKS, it's going to say simplify. I got to think of a number that can go into 2 and 8. The same number. You know what? If it's even, always just trust your 2. 2 goes into negative 2, negative 1 times. 2 goes into 8 4 times. There is your simplified number. So if you get negative 2 over 8, ALEKS is real good about telling you straight out, saying, hey, try it again, but simplify. Your turn. Good luck. Okay, we got one last problem here, example number 6, and then you're going to have your chance to go to your ALEKS and work out your homework. So here we go. Number 6. About 6/100ths of the population of the United States lives in Florida. Another 400/100ths lives in Ohio. About what fraction more of the U.S. population lives in Florida than Ohio? Okay, take out my highlighter. 6/100ths of the people live in the United States live in Florida. I got 2 highlighters here, so 4/100ths live in Ohio. About what fraction more of the U.S. population lives in Florida than Ohio? So in other words, how much more? So I'm going to change my color again. More. We are trying to find what we call as the difference. And when we find the difference, we like to, you guessed it, subtract. So, or how much more? All means to subtract. Difference, how much more? Subtract. So you are going to get that 6/100ths minus 4/100ths. Now some of you are already thinking, hey, these are like fractions. Well, 100, 6 minus 4. Should already know that by now. 6 minus 4 is 2. I get 2 hundredths. That's not simplified. Even, divide by 2. 2 goes into 2 one time. 2 goes into 150 times. 1/50th more. That's what that means. 1/50th more of the U.S. population lives in Florida than Ohio. 1/50th more. We found the difference between the two states. Okay, this concludes our notes. Make sure you have the notes. Make sure that you put them in a notebook. You can go back and watch this at any time. Make the notes better, highlight, all of that neat stuff. Good luck.